Hello there. In this webcast, we will be talking about functional groups. Understanding functional groups is critical to understanding organic chemistry, but even before that, to simply talking about organic chemistry. This webcast will discuss what functional groups are, why they are important, and how to identify and name them. There are many ways to take atoms and connect them and put them together. Fortunately for us, there are many combinations of atoms that are common in organic molecules that appear all the time. We take these particular combinations of atoms and we give them names. These named combinations are what we call functional groups. We call them functional groups because these combinations of atoms give the molecule its unique chemical properties. They give the molecule its function. Being able to identify functional groups in a molecule is incredibly important in organic chemistry because it is those functional groups that you will use to perform chemical reactions. To begin with, we're going to talk about carbon functional groups. Organic molecules that are comprised entirely of carbon and hydrogen are what we call hydrocarbons. An example of a hydrocarbon would be gasoline. There are two main types of hydrocarbon functional groups. The first are what we call saturated carbons. Saturated carbons are carbons that contain only single bonds, carbons that are sp3 hybridized. Here in the upper left, we see a carbon that is attached to 3 hydrogens. You also see that there is this line, this bond, going over to the left. All this is showing is that this carbon is attached to something here on the left. We call that a methyl group. If we take that same carbon, but replace one of the hydrogens with another bond, again to some atom, now we have a carbon that is still sp3 hybridized, but is attached now to only 2 hydrogen atoms. We call this a methylene. If we continue the pattern, we replace another hydrogen with another bond to some atom. Now we have only 1 hydrogen attached to our sp3 hybridized carbon. This is what we call a methine. For these first 3 entries, it didn't matter what was connected to the carbon. For a quaternary carbon, it must be bonded to 4 other carbons. Whereas for the others, for the methyl, the methylene, and the methine, they can be bonded to carbon or heteroatoms, such as oxygen and nitrogen. Keep that distinction in mind. Now that we have discussed saturated carbons, let us discuss unsaturated carbons. Unsaturated carbons are sp2 or sp hybridized. Here in the upper right, we have what is called an alkene. You might also hear alkenes referred to as olefins. They mean the same thing. We have 2 carbons that have a double bond connecting them. This carbon-carbon double bond is what we are talking about when we say alkene. In an alkene, we can have hydrogens or carbons attached to it. If we take 3 alkenes and connect them in a particular way, we get what is called a benzene ring, which you can see down here. A benzene ring is not an alkene. A benzene ring is comprised of alkenes, but they are not the same. They undergo different chemical reactions. When you take a benzene ring and you connect it to something, when you bond it to something, it's called a phenyl ring. In organic chemistry, when you were talking about this type of structure as a functional group, you will always refer to it as a phenyl ring. A phenyl ring is a type of aromatic ring. You do not need to know what an aromatic ring means right this moment. It will become much more important when we discuss NMR spectroscopy. And finally, here at the bottom, if we have a sp hybridized carbon and an sp hybridized carbon connected via a triple bond like we do here, we have what is called an alkyne. In case it is difficult to see, there are in fact carbon atoms here at the intersection. So if you see an alkyne, remember that. These are the names of the most important carbon functional groups you will find in organic molecules. Over time, these names will become second nature to you. If you are taking Chem 232 concurrently, you'll be doing this in Chem 232 as well. You can think of this as studying one thing for two different courses. Now let's move on to non-carbon-based functional groups. Let us start with molecules that contain halogen atoms. Here, I'm showing a chlorine atom. I could use a fluorine atom or a bromine atom or an iodine atom here, and it wouldn't change. Whenever you have a halogen attached to a carbon, that is called an alkyl halide. Now let's talk about oxygen-containing functional groups. If I have an oxygen that is connected to a hydrogen atom and a carbon atom of some kind, this is called an alcohol. If I take that same oxygen atom, but connect it to two carbon atoms, it is now called an ether. Now let us discuss nitrogen-containing functional groups. On the right, we see three types of nitrogen-containing functional groups. If I have a nitrogen connected to two hydrogens and a carbon, this is called an amine. In this particular case, it is called a primary amine. If I take the same amine and now I connect it to a carbon atom, instead of a hydrogen, it becomes a secondary amine. If I take that same amine and now connect it to three carbon atoms, it becomes a tertiary amine. Hopefully you can see the pattern. One carbon atom, primary amine. Two carbon atoms, secondary amine. Three carbon atoms, tertiary amine. All these functional groups are amines, and so if I ask you, what type of functional group contains a nitrogen atom? If you respond an amine, that is a correct answer. If I ask you to be more specific, then you can say primary or secondary or tertiary amine. One note before we continue. For alkyl halides and alcohols, there are primary alkyl halides, secondary alkyl halides, and tertiary alkyl halides. Similarly, there are primary alcohols, secondary alcohols, and tertiary alcohols. That naming system is completely different from the naming system for amines. If you are concurrently taking Chem 232, you will learn about that nomenclature as you start discussing elimination and substitution reactions. The final type of functional group we are going to discuss is the carbonyl. A carbonyl is a carbon double bonded to an oxygen. It doesn't matter what that carbon is attached to. Whenever you have a carbon double bonded to an oxygen, that is a carbonyl. Carbonyls are incredibly important functional groups in organic chemistry. As a result, it is important to be able to recognize and name all types of carbonyls. As you might imagine, there are many different things we can attach to this carbonyl. Every combination has a particular name. This is because every combination performs different chemistry. For this course, here are the 5 types of carbonyls you need to be familiar with. Here on the left, we have what is called a ketone. A ketone is when you have a carbonyl that is connected to 2 carbon atoms. If you look down below, we have what is called an aldehyde. An aldehyde is a carbonyl connected to a carbon atom of some type and a hydrogen atom. This is a very small change, isn't it? We've simply exchanged a carbon atom for a hydrogen atom. But this has incredible consequences for chemical reactivity. It is important that you are able to distinguish them. In the upper right, we have what is called a carboxylic acid. We have an OH group, but this is not an alcohol. Previously, I told you that an alcohol was an oxygen connected to a carbon atom and a hydrogen atom, and in most cases that is true. In this case, however, we do not keep the OH separate. In this case, we treat the entire package as a functional group. Note how I have circled the carbonyl and the OH. They cannot be treated as separate components. They are one whole. Similarly, down below, we have what is called an amide. This NH2 is not an amine. We treat this combination of atoms as a single entity. So when you have a carbonyl attached to an N of some kind and a carbon, you have what is called an amide. This particular amide is a primary amide because this nitrogen is connected to one carbon and two hydrogen atoms. A secondary amide would replace one of these hydrogen atoms for a carbon atom of some kind. It is the same naming scheme you saw with the amines. Finally, down below, we have a carbonyl that is attached to an oxygen, like we saw with the carboxylic acid. However, it is an oxygen that is bonded to a carbon, not a hydrogen atom. This type of functional group is called an ester. To recap, a carbonyl is a carbon double bonded to an oxygen, connected to some other atoms. There are many different types of carbonyls, and you will learn about these in Chem 232. For this course, these 5 carbonyls are the most important carbonyls to be able to recognize and name. For some practice, let's look at these line structures and let's identify what functional groups are present in these line structures. I will walk you through the one in the upper left. Here, what do we see? I see a carbon-carbon double bond here, which I know is called an alkene. I see several CH2s, which I know are called methylenes. I see this CO, which is a carbonyl. But what kind of carbonyl is it? Well, this carbonyl is bonded to a carbon on the left and a carbon on the right. Therefore, this particular carbonyl is a ketone. And finally, here at the end, I see I have a methyl. And there we go. I have identified all of the functional groups present in this line structure. Now what I would like you to do is pause the video and spend some time identifying the functional groups present in the remaining 3 line structures. When you're ready to check your work, unpause the video. Welcome back. Let's see how you did. Let us look at the structure in the upper right. You may have noticed that there are carbon-carbon double bonds here in this ring, like there was in the structure on the left. You may have named each of these as alkenes. It is true that these are carbon-carbon double bonds. However, recall that when you take 3 carbon-carbon double bonds, when you take 3 alkenes, and you connect them in a particular way, they form a different functional group. These would not be called alkenes by an organic chemist. Instead, an organic chemist would recognize that this, as a whole, is called a phenyl ring. And this distinction is important. Alkenes undergo different chemical reactions than phenyl rings do. Alkenes have different properties, including spectroscopic properties, than phenyl rings do. And you'll see that when we start talking about spectroscopy. That's most of this molecule. The remaining pieces of it are simply a series of methylenes. So that wasn't so bad. Hopefully you now recognize the differences between a simple alkene and a phenyl ring. Now let's look at the structure in the bottom left. What are the functional groups present here? We have here on the left a methyl. We have here an OH, which we know is called an alcohol. Know that there are 2 hydrogens attached to this carbon, therefore this is a methylene. And finally, we know that this OH is not considered to be on its own because it is attached to a carbonyl. So we recognize that this entire thing is what we call a carboxylic acid. Hopefully you were able to distinguish the alcohol from the carboxylic acid. These two OHs are not the same. Now let's look at the final structure. We have a methyl here, farthest left. We have a large number of methylenes. Now let's look at these heteroatoms. The one on the right, we know is an amine. That is a correct answer. If you wanted to be more specific, you could say that this is a primary amine, but it is not required unless it is relevant. And by relevant, I mean I ask for it, or the distinction is important when we talk about spectroscopy, and we'll see an instance of that later in the course. Now let's look at this oxygen. We have this oxygen that is attached to a carbon on the left and a carbon on the right. Therefore, this oxygen is part of what we would call an ether. And there we go. We have identified all of the functional groups that are present in these line structures. Hopefully this was helpful to you. Being able to interpret line structures, and that includes identifying the functional groups that are present, is crucial to your success in organic chemistry. That brings us to the end of this webcast. To recap, functional groups are common combinations of atoms in organic molecules. Different functional groups will do different chemistry. Sometimes functional groups can be similar in both structure and in name, but they are all different. It is incredibly important to be able to distinguish between each type of functional group, even if there's only a small difference between them, because that small difference in terms of structure can have massive implications for their chemistry. For example, in this webcast, you saw many different types of carbonyl functional groups: ketones, aldehydes, esters, and so on. While they all have a similar motif, they all have a carbonyl, a C double bond O, they are all different, and you should treat them differently. For similarities in name, simply look at ether and ester. Confusing those two functional groups is common when learning about organic chemistry for the first time. While the names are similar, the functional groups are quite different. And so when memorizing these functional groups, do ensure that you are not confusing one for the other,